Try putting that on here. Okay, so if we call this point xy, then here's some things that we do know. We know that for any value to be on the semicircle, we have y would have to be the square root of r squared minus x squared, the equation for a semicircle. Also know this, that this length here would be x, and this here would be x. So if I'm looking for the length here, it would have to be 2x. So let me just adjust this area formula a little bit. The area is the length, 2x, times the width, that is the height of this. And the height of that would be the y value, that is the square root of r squared minus x squared. Of course, we're thinking of r here as being a constant. So r is the radius, which means r has to be bigger than 0. In fact, so do x and y, don't they? Okay, so here's our area formula, and this is what we are trying to maximize. So if we're trying to maximize area, then we're going to take the derivative and we're going to find the critical numbers. So here's my formula for area, equal to 2x square root r squared minus x squared. What's the derivative of that? Well, I'm going to need a product rule. It's the first function times the derivative of the second, which would be 1 over 2 root r squared minus x squared, times the derivative of the inside function, negative 2x. Plus the derivative of the first function times the second function, r squared minus x squared. Yeah. Oh, because when I take the derivative of this inside function, you're wondering why I don't have a 2r in here? It's because r is a constant. Good question. Okay, simplify. I guess we've got a 2 canceling, and I'm left with a negative 2x squared. Over the square root of r squared minus x squared plus 2 square root r squared minus x squared. I am now regretting using radical notation. I think it would have been easier to use exponential and factor. So let's give these a common denominator. That is, we're going to multiply this one by root r squared minus x squared over root r squared minus x squared. And it gives me negative 2x squared over square root r squared minus x squared. And when I distribute this one on the top, the root comes off, and I get plus 2 bracket r squared minus x squared. So carefully collect like terms on the top, watch your signs, and simplifies to 2r squared minus 4x squared all over square root r squared minus x squared. Okay, just a little note here. I guess when I went to the domain of this function, I said r had to be greater than 0. In fact, r has a restriction on it as well. It would look No, it doesn't. X has a restriction on it. R has to be greater than 0. Look at this. If it's a semicircle, X has to be smaller than R. So if I look at my X value, it would be stuck in between 0 and R. Right? I can't have I can't have an X value bigger than R. It could equal R, but it can't get bigger. And you can see that from here as well. You can't take the square root of a negative number. I guess from here to begin with. Okay, and then what are we looking for? Critical numbers. So critical numbers, we're not going to get one on the bottom because of our domain restriction. But we will get one on the top. That is if 2r squared minus 4x squared is equal to 0. So for critical numbers, solve this. 2r squared is equal to 4x squared, or r squared is equal to 2x squared, dividing both sides by 2, or I'm trying to solve for x. How about I do this? 1/2 r squared equals x squared. Square root both sides. So I get plus or minus r root 1/2 is equal to x. Or plus or minus r root 2 over 2 if you rationalize. Okay, then. So then what would be our y value? Our corresponding y value would be found if you put this back into here. So what does y equal? It equals the square root of r squared minus, I think this is the easiest way to use it. Square root 1/2 r squared squared. So then when you square the root comes off, and I get r squared minus r squared over 2. Which would be square root of 2r squared over 2 minus 1r squared over 2 gives me just an r squared over 2. Which gives me r root 1/2, which means our x, y values are the same. So we've got this kind of a shape. So our x is r root 1/2 and our y r root 1/2. Did I answer the question? No. It said to find the largest area. So here's my largest area. Area is equal to 2x square root r squared minus x squared. And what's my x? It is r root 1/2, r root 1/2. This ends up being exactly the same, right? This is the y value, which is making this way more complicated than it needs to be. 2r root 2, and r squared minus r squared over 2 is going to give me 2r squared minus r squared over 2, which is r root 1/2, and this is 2r squared over 2. I believe it just gives me r squared for my area. I'm going to shut this off and then we'll talk it through, okay?